Conic section. A conic section or a conic in short is a curve of intersection of a plane with a right circular cone, or more appropriately a double cone. So which means it's something like this. Two cones attached to each other at the vertex. So here there is a intersection between this double cone and a plane, right? So this point of intersection, so here it would be intersecting at like this. So this curve of intersection is called a conic section. So which means here a double cone basically has two nap extending indefinitely in both directions. So a more appropriate way of drawing this would be to put it like this, right? So here putting this arrow would be more appropriate because it extends indefinitely. A generator of the cone is a line lying in the cone. Now as you can visualize, the curve of intersection depends on the inclination of the axis of cone to the cutting plane. Okay, now let's see what this means. So let's say this is our cone. Now here, if our plane of intersection is cutting this double cone like this, now this is called a parabola, or it might also cut it like this. So here you have this, and we have a plane which is cutting it like this. So here you have this, and you also have this. So this looks like this, whereas this looks like this. So this is called a hyperbola. And then you have another where the plane cuts it. Yes, this is called an ellipse. Another way of looking at this is if the cutting plane is parallel to one generator. Remember, generator is a line. Then it is a parabola. If the cutting plane is parallel to two generators, then it is an ellipse. And if is parallel to zero generator, it has a generator but it is not parallel to, so the cutting plane is parallel to zero generators, then it is a hyperbola. So all this is fine. Now let's look at the definition. So a conic section is the locus of a point which moves such that its distance from a fixed point has a constant ratio to its distance from a fixed line. So let's say we have a fixed line and a fixed point, right? And we have a locus of a point. So this is, let's say, the point on the conic section. This is a fixed point and this is a fixed line. So if we drop a perpendicular from this line to this point and we connect these two, right? So let us say this is S, this is P, and let's say this is M. So what the definition says is that the ratio of SP and PM is a constant, and that constant is given a special letter, that is E, which basically means eccentricity. So remember, the moment we say locus of a point, that means this point is not stationary. As we move it, this ratio remains the same. So let's say we have another point, right? So this is equal to this, then this is, or rather the ratio is same, ratio is same, ratio is same. Now, as you notice, if you connect these points, you will end up with a particular shape. In this case, it is a parabola. So, what type of shape? The shape could be like this: fixed point, fixed line. It could have been this way. Okay, so here again there is a particular ratio to this distances, right? So if this ratio is equal to 1, right, which is what here I have tried to maintain, PM is equal to PS. If E is equal to 1, that means conic is a parabola. Now, if E is less than 1, conic is a ellipse. If E is greater than 1, conic is a hyperbola. So, which means SP by PM equal to 1 means what? SP is equal to PM. This distance is equal to this distance, and it remains equal throughout the curve, right? Okay, so that is parabola. Now, if SP by PM is less than 1, it implies what? SP is less than PM. Remember, here this is S, this is P, and these points are M. So fixed line, fixed point. So this is M, this is P. So SP has to be less than PM. Now if you maintain that ratio, you will get a ellipse. Similarly, SP by PM is greater than 1 implies SP is greater than PM. So here again SP is greater than. So again remember, you have to maintain that ratio. So here you will notice it will come like this. Here it will come. This is ellipse. This is hyperbola. I have not drawn it fully, so it may not actually look like a hyperbola. Okay, because on this side also it will come. So we'll get into the details as we go along. Now, here the vertical line is the directrix, the fixed line, and the fixed point is called the focus. Okay, so let's take an example and have a look at this. Now let's say E is equal to 5 and S is at 2, -1, and the directrix, let's say L, is 3x minus 4y plus 1 equal to 0. So equation of the line is given, the fixed point is given, and the eccentricity is given. Okay, so let's say P x comma y is an arbitrary point on the conic, and S2 comma -1 is the focus. And using a normal, standard letters, this is S, this is P, this is M. So PM is the perpendicular distance of Px comma y from 3x minus 4y plus 1 equal to from this line. Okay. Now we know that SP by PM is E, right? So which means we can write this as SP is equal to E dot PM. Now SP, we have the coordinates of S, we have the coordinates of P. So SP can be written as square root of x minus 2 square plus y plus 1 square is equal to E, we know is 5, and we know the distance, perpendicular distance of a point from a line, we know that is magnitude of 3x minus 4y plus 1 divided by the square root of 3, that is 9, plus square of 4, that is 16. Okay, now to simplify it, let's square both the sides. So when we square, the square root disappears. So let's take, okay, x minus 2 square plus y plus 1 square. 5 square is 25. 3x minus 4y plus 1 divided by, again the square root disappears. 16 plus 9 is 25, and this is square. Now simplify it further. X square minus 4x plus 4 plus y square plus 2y plus 1 equal to, and this side we have to square it. So 9x square 12xy plus 3x, then minus 12xy plus 16y square minus 4y, then plus 3x minus 4y plus 1. Okay, x square plus y square minus 4x plus 2y plus 5 equal to 9x square plus 16y square minus 24xy plus 6x minus 8y plus 1. Let's bring it to this side. So minus 8x square minus 15y square minus plus 24xy plus 10x, no, minus 10x, minus 10x plus 10y plus 4 equal to 0. Let's multiply everything by minus 1. So 8x square minus, okay, plus 15y square minus 24xy plus 10x minus 10y minus 4 equal to 0. So this is the equation of the conic section based on those parameters, and the parameters are the eccentricity is 5, and the focus is at 2 comma minus 1, and the line equation of the line is this. Okay, so now if you look at this, if we want to make it generic, what would we do? We would say this is ax square plus by square minus, now we would normally try to avoid making it as negative, so let's make it plus. Okay, and the number itself, the variable itself or the coefficient itself could be a negative number, but let's make it as 2 times of something else. So 2hxy plus 10x. So let's make it as 2gx plus 2fy plus a constant 0. Constant c equal to 0. So if you have seen the previous sessions of circles, here there also we had similar kind of equation. The only thing was xy was missing, and a and b has to be either 1 or it has to be equal to each other, so that it can get cancelled when we divide it by that number. Now this can be simplified further by choosing the appropriate coordinate system. So that we will look at in our next session. Bye for now.